Okay, so we're gonna start studying for the test, and the first thing that you need to be comfortable with is what are the stages of a product's life cycle? Doesn't say products, but of a product life cycle. So who remembers what the stages are? Which one, Bryn Mawr?
Producing.
What'd you say?
Producing.
Okay, so we called that manufacturing, but before that there was one. What? Taylor?
It's a raw material.
Raw materials, right. So we start with the raw materials, then we manufacture, and then
Useful life.
useful life. And finally, solid
Disposal?
or what do we,
Recycling?
disposal or recycling, and we call that, as far as the life cycle, what do we call that?
End of life.
End of life. Okay? So you're right, Sully. It's disposal. And a lot of times disposal ends up being what, guys? Landfill. Or it could be recycled or reused. Oh, I put that in the wrong place. Sorry. That's end of life, not useful life. Useful life then is what? How do we simply define what useful life is?
Product.
When you use the item as what it was meant to be used for.
Right, so whatever the use of the item. So if it was a computer, you use it as a computer. If it was a bottle, you store soda in it, whatever it was. Manufacturing, of course, is when we make the product, and the raw materials comes before, because we actually have to get the materials to make them. All right. So one question I have for you related to this is, do all the stages of life cycle involve waste? Or have an impact on the environment? Taylor?
Yes.
Absolutely. Absolutely. How would it be in the case of raw materials? Madeline?
You have to
You have to mine them. You have to mine them. So you need the equipment for the mining, the electricity, or energy. You also have to have the trucks to pull it out. So a lot goes into raw materials. Plus there can actually be waste left over from mining. Manufacturing, where's our environmental impact with manufacturing? Madeline? Madison, sorry.
It kind of depends on what you use to make it, like you did process smoke and I guess.
Okay, so the waste from the actual manufacturing, so like in our cases with the circuit boards, it was the copper chloride. What else happens? What else, Taylor?
People are going to have to build different buildings and stuff to actually do the manufacturing.
Okay, so they have to build the building, so that takes up your resources. It also takes up energy. Does the actual manufacturing use energy? Yes, lots of energy, right? Lots of energy, electricity. Okay, so manufacturing creates a lot of waste, uses a lot of energy. Useful life, how about useful life? Useful life have an impact on the environment? Madeline?
Isn't it like an electronic, wouldn't it use electricity?
Okay, if it's an electronic, it'll use electricity. If it's a glass bottle or an aluminum can or a plastic bottle, it takes a truck to deliver it. Then if they put it in a refrigerator at the gas station, it uses electricity there. So there still is some use of electricity. Maybe not a lot of waste, but definitely a lot of use of electricity. And then finally, end of life. Well, that's our biggest question, right? If we throw it in the landfill, then it has a huge impact on the environment. if we recycle or reuse it, that reduces the impact on the environment, right? Okay. Questions about this? Feel pretty good about this? I will tell you, you will see this again at the end of the year with your ECA. Okay, so this is something, don't let it just go out of your head since we're done with chemistry. Yes?
So environmental impact happens like every time?
There's environmental impact at all stages of a product's life cycle.
Okay.
Yep. Okay, so what are the elements, now we're really flipping gears, what are the elements that make up plastics? Who remembers when we made those models? Reagan?
I know they're like something to do with polymers.
They are polymers. What particular elements though? Specific elements. Katie?
Hydrogen. Oxygen.
Oxygen, yeah. Oops. Remember the last one, Sully?
Carbon?
Carbon. Hydrogen, oxygen, and carbon. Those are the three elements that make up polymers. Now they can have other things added to them, but those are the base ones. Okay? Questions about that? All right, physical properties of a substance. We spent a whole lot of time in this unit talking about physical and chemical properties. Who can tell me some examples? Well, first off, tell me what a physical property is.
Something that you can like see or like know.
Okay, so something we observe using our senses. Okay, so what are some examples? Taylor?
Color.
Color? What else?
Texture?
Texture?
Smell?
Smell?
Strength.
Strength? Taste, but don't do it. No, don't taste. But taste would definitely be a physical property, you're right. Just since I'm putting it out on the internet. Flexibility.
Electrical conductivity.
Great. Conductivity. What else? Luster would be one, definitely. We're going to be using luster in our next, well, in 2 units from now.
Size.
Okay, size. What do you think about size?
The size can be changed, like it depends on what you do with the
We could actually make, depends on what you're talking about size. If you're talking about the mass of one compound, and you're talking about mass, a very specific thing, then yes. But I could give you a long piece of plastic or a short piece of plastic, and it's the exact same plastic. Remember when we did the test with the plastics, we had the long strip and the short strip? So I'm not going to put size down there for that reason.
Hardness.
Hardness.
buoyancy,
Okay. Buoyancy, I think this is right. Yes.
ability to transmit light.
Okay, so light transmission. Okay, we've got a lot of them. There's one I want to ask you about. How about this one? Is that physical or chemical? Physical. Why is it physical? Taylor?
It doesn't involve a chemical reaction.
Right, it does not involve a chemical reaction. Yes?
What about mass?
If we're talking about the atomic mass of something, yes. If we're just talking about mass in general, the mass can vary just like the size. Yes.
Aren't buoyancy and density kind of?
They're very similar, yeah.
Okay.
Although density is talking actually about its ratio of mass to volume. Buoyancy is a result of the density. Whether it's buoyant is a result of what its density is. Does that make sense?
Yeah.
Okay, everybody good on that one? Questions? Okay, so chemical properties of a substance. Somebody explain to me what a chemical property is.
A property through a chemical reaction.
Okay, so a property related to a chemical reaction. Okay, so what are going to be some chemical properties? What are some chemical properties that we've seen?
Reaction to copper chloride.
Okay, reaction to copper chloride.
A gas forming?
Okay, gas forming.
Temperature change.
Temperature change. Fred?
Color change.
Color changing. And guys, don't get confused with this one. Color change is different than its color. Okay, so this means that it starts one color and it ends up a different color. So we've seen a color change. Madison? Precipitate. Yes. Who can tell me what a precipitate is? Ethan?
It's like a substance, it's usually a colloid or a solid, and it's left behind after a chemical reaction.
Okay, so it's a solid or a semi-solid, such as a colloid, that's formed as the result of a chemical reaction, usually between two liquids, but we actually saw it between a liquid and a solid, didn't we? When we added the metal to reclaim the metal. Reagan?
Bubbling or fizzing?
Okay, bubbling or fizzing.
Corrosion.
Corrosion. All right, I think we've got a good list. Questions about chemical properties of a substance? Okay, periodic table of elements. You will have a periodic table of elements to look at, okay, tomorrow. So let's say I give you the element magnesium, and I say to you, what type of element is that? Somebody who's up close and can see. Jess?
Alkaline earth metal.
It's an alkaline earth metal. So you're going to use the chart, and you can always use a periodic table. They may vary in the way they are set up or their color codes, but almost always they have some kind of table that will tell you what the alkaline earth metals are, the alkaline metals, non-metals, noble gases, rare earth, other metals, and halogens. So all you have to do is be able to look on the table. Okay? Questions about that? You will. I've already got them printed out, so you will have these. I will ask that you return them to me just because I'll need them for other classes. All right. Questions? Okay. So we have a compound, C6H12O6. That's actually the compound for dextrose. You don't need to know that, but I'm just telling you. So how many atoms? How many atoms are in this compound?
24.
24. Anybody not understand why there are 24 atoms in this compound? Okay? How many molecules are there? Brady?
3.
Molecules. Sully? One molecule. Remember, atoms Molecules are made up of 2 or more atoms chemically bonded together. We've got 24 atoms here chemically bonded together, just one. Now, if I did this, Brady, how many molecules would I have? 3. Very good. All right. And then how many different elements? Claire?
3.
3. And the different elements are carbon, hydrogen, and oxygen. Does that make sense to everybody?
Yeah.
Yes.
So that made her plastic.
Actually, no, this is a sugar. This is a sugar, dextrose, okay? So just plastics do have, that's a great question though. Plastics are made up of carbon, hydrogen, and oxygen. And what you'll begin to see as you take high school chemistry is it has to do with the ratios of the carbon, hydrogen, and oxygen as to whether it's a plastic or something else, which is pretty amazing when you think this is sugar and those same atoms, if they're mixed differently, can make a plastic. Yes?
So with the molecules, it has to be 2, is it 2 elements or atoms?
Well, okay, it is 2 elements, but it could be 2 of the same elements, which would be 2 atoms. So remember, we use those words kind of interchangeably. Element, we're usually talking about the element carbon. If we're talking about how many atoms of carbon, we say 6. So it's sort of more of a, a word choice, okay? Everybody okay on that? Okay. All right, an element contains blank type or types of atom or atoms. What's the word that goes in there? Reagan? 1. It's a pure substance, so it's sodium, or it's chlorine, or it's carbon, or it's magnesium, or it's hydrogen. Those are elements. They're only one type of atom that makes those up. Yes?
Why did you add S after type?
Because if it was many type, 1 gave it, see, I put a dash there to say, so that you had to choose whether it was 1 or more. There shouldn't be an S there. But I didn't want to give the answer away. Okay? Everybody okay with that? Understand that? All right. Okay, which of the following are compounds? Which of the following are compounds? And you can just tell me the letters if you don't know what they are. Are compounds. Which is 1, Garrett?
CO.
Right, CO. CO is carbon monoxide. Carrie?
H2O.
H2O. We know that one, it's water. Ethan?
NaCl.
NaCl, carbon, or sodium chloride, okay? Now, the rest, C, capital C small a, H, capital N small a, are all atoms or elements, okay? How do we know that this capital C, capital O is a compound and not the name of another element? Lindsay?
Because it was just Cl, the O would be lower.
Right. If there was an element that was named CO, it would be capital C, small o. The capital letter indicates a new element. Very good. Questions? All right. What is a chemical reaction? How would you define a chemical reaction? Ethan?
Is it when 2 chemicals react with each other and it produces more substances that started with? Sometimes, like, it might release a gas or it might leave a precipitate.
Okay. So it's when two or more chemicals combine and create one or more new chemicals. So it could conceivably only create one new chemical. But if it creates something new as the result of the combination of two or more being combined, or in some case heat being added, but in our situation, we usually are talking about two or more, then that is a chemical reaction. And we go back to prove the chemical reaction has occurred, we use what kind of properties? Chemical properties. So chemical properties are proof that a chemical reaction has occurred. Okay? Yes?
But can't nothing be created or destroyed during chemical reaction?
Correct. Nothing can be created or destroyed during a chemical reaction. Therefore, all the atoms that are here have to end up here. They're just recombined. Remember? They're just recombined. They're all still there. They're just recombined. Yeah.
If you like add a substance and you like burn it, like incineration, like what? How is that a chemical reaction if you don't have like two substances?
Well, that is one case where that is not the chemical reaction. The actual adding of heat or fire is breaking down the chemical composition instead of combining two. So you're adding heat or you're adding fire that is in fact creating the chemical change. All right, so what are these things that we start out with called in a chemical reaction? Brennan? Reactants, right. These are reactants. And what we end up with is called, Taylor?
The product.
The products. And Garrett, back to your question, if you were to sit down and add up how many of each of these elements we had, they would be equal on both sides. So they've been recombined, but it has not been created or destroyed. Okay, questions about that? All right. Okay, we know evidence of chemical reaction. Where can we find that? We don't even need to write it down again. We've already written it all down. Where did we write it down on our notes? Katie?
Chemical properties.
Yeah, the chemical properties. The chemical properties are the signs of chemical reaction. Okay. What's this stand for?
Parts per million.
Parts per million. You are going to have sort of a fraction question. So let's say I said that something had 100 parts per million. How would I write that as a fraction? 100 parts per million. Darian?
Didn't you put 100 over a million?
Right, 100 over a million. And remember, the parts per million, the unit is not listed here. So we could be talking about drops, we could be talking about ounces, we could be talking about liters. It's whatever unit you want to talk about, okay? All right, when waste is created, when is waste created in the life cycle of the product? We already talked about that, right?
It's created in every step.
Right, it's created in all stages, and if you want to go back to your notes and look, but in all stages it is created. Either through the use of energy and transportation, creation of the product, the waste products that are given off, and then certainly when we get rid of it. Okay, why did we use ammonia as an indicator in our experiments? Why did we use ammonia? Brady?
Because if there's copper in something, it makes it turn like blue or something.
Okay, if there's copper in something, it makes them turn blue. And what? Why would the use of an indicator be important? Taylor?
Because when we had copper present, we couldn't see that just with our senses.
Right. When we had copper present, we couldn't, especially in that dilution activity, when it got down to pretty low dilution, we couldn't really tell for sure if there was copper or not, because it certainly was no longer that blue-green color. So it helps us when we cannot see it with our own eyes. Okay, very good. Questions about that? All right, make sure that you're comfortable with what dilution is, incineration, and reclamation. I'm not gonna go back over them again because you have them in your notes. Question?
For incineration, where did the copper? How is there not still copper? Because wouldn't there have to be copper somewhere?
Wouldn't there have to be copper somewhere? Yes, there would have to be copper somewhere, and for the most part, well, we did have some left in the ash, and then there was minimal in the smoke, but it broke it down into a level that was usable. Personally, I think incineration's not a highly effective method because it is kind of hard to determine where that copper's going, and you certainly can't reuse it. So it's, and neither of our experiments were super great at going over where that copper went. Reclamation, just remember there's kind of two purposes. One is to get rid of the waste, but one is also to reuse that copper. Okay? Any other questions about this? We spent a fair amount of time on that. Okay, so what are some ways that we can reduce waste from manufacturing that we can do right now? What are some ways that we can reduce waste from manufacturing?
Well, we can reuse
Okay.
things that can be reused.
Reuse things that can be reused. What else?
Only buy necessary things.
Yes, only buy don't just buy something because the newest thing is out. If your old one works, keep it. Now if your iPod is broken, well, yeah, you got to get a new iPod or your cell phone. But if every time a new iPhone comes out, you have to get it just because you have to get the next best thing, then you are increasing the amount of waste. What was a plausible answer to the waste issue that was presented in our textbook at the very beginning of the unit?
Some girl was going to get a new phone, and she saw a recycling symbol over a couple of phones, and she asked an employee about what that meant, and he said that they reused parts from old phones and made that phone with the parts from the old phones.
Okay,
And she went that way.
so buying green, and they are, I can't remember, did somebody in here tell me that there are some electronics that are green electronics now?
Yeah, there are a lot of Nokia phones that are
Oh,
green.
okay, so,
Smartphones.
well, definitely, I know there are products outside of, I mean,
They're not-
lots of paper products are green, paper products like reused. So buying green will definitely help. Okay, so reuse things that can be reused, only buy necessary things, buy green. There is a question on the test. Please read this question very carefully. It's a little worded trickily. I can't say that word right. So, all right, here's your essay questions. I'm not going to really go over the answers to them, but just to give you an idea, you will have a property chart and an unknown, and you'll be asked to determine what the unknown is. We've done a fair amount of that. You'll be asked to choose the best method of treating waste. They will give you 4 different waste treatment options, and you will have to make a determination, and then there will be an evidence and trade-offs decision. Read the questions carefully. If it requires a trade-off, be sure you put the trade-off in. If it does not suggest that you need a trade-off, this question probably will not be rat seed, but both of these questions will need to be rat seed, and I will remind you tomorrow about that, but these questions, it'll be very important for you to give me evidence, although I will say this one you have to give evidence to, but it's a shorter answer question than the other two. Okay, I'm gonna stop the video.